kilogram car M2, which is at rest. The two cars locked together and skid 12 meters on a level surface before stopping. Police determined that the coefficient of kinetic friction between the tires and the road was 0.7, was the first car exceeding the 45 miles per hour speed limit. So to solve this problem, I will use the momentum and energy equations. So for the energy and momentum approach, we know that momentum is conserved. And because the two cars locked, the general equation will be m1v1 equals the sum of m1 plus m2 times v2. Plugging in numbers, it would be 1120 v1 equals 2540 v2. We will also be using kinetic energy, which accounts for the frictional force. Thus, we know that the general equation is for kinetic energy is 1/2 mv squared. So plugging that in with the specific variables for this problem, m1 plus m2 times v2 squared over 2 will equal the work of the road, which is the frictional force times the displacement. So here I just simply plugged in the numbers for each of the variables. To solve for v2, which will be the velocity of the two cars traveling together, you can use basic algebra to cancel out the mass from both sides, and then plug in the numbers to solve for v2 squared. And taking the square root, you see that v2 is equal to 12.83121 meters per second. So going back to the first equation we had for momentum, you can plug in the value of v2 to get v1, which is 29.09935 meters per second. But it is important to note that the units here are meters per second and not miles per hour. So then by using the conversion that 1 meters per second is equal to 2.23694 miles per hour, you can solve for approximately 29 meters per second, which gets you approximately 65 miles per hour, which you see is greater than 45 miles per hour, which is the speed limit. So the first car was indeed speeding.